Hi everybody, welcome to our next part of our TK-80U Kenwood receiver video. And I just want to start out by expressing how appreciative I am of all of you. I bet you it wasn't 10 minutes after I posted this video that, as soon as you all started watching this and got into it, that I got flooded with emails and comments helping me find the correct schematic for this. Now, nobody so far has been able to find an actual service manual for this model, and there are still some unanswered questions about this receiver, and I'll try to go over that during this video a little bit. But thanks to a couple of you, and through the email, you've emailed me an actual schematic for this, and I'll show it to you real quick. And you can see right up here where they're showing the vacuum tubes. I don't know if you can see them in there or not, but they're in there. So that's the correct, looks like the right schematic. That's good news. Now, we don't have any kind of calibration or anything, but that's okay. We don't care about that. So I just wanted to thank all of you for all of your efforts. I know in the comments I got a lot of links also that I followed. So far, all we've been able to come up with was that schematic, and we have not been able to get a total service manual, like I say, with parts layout and everything, but I think we can figure it out. I think there's enough similarities with the all solid state version of this. And like I said, I will show you over here. Let me see if I got this on the camera or not. Right up here, can I zoom in? You can see right there, up here, it says TK-80U. And no, this is an original, I don't know if it's focusing or not, but this is an original faceplate. There is nothing that I can tell, anyway, that this has been replaced or anything. So, I don't know. I mean, it's a mystery. So, what we're going to do for this video is I've determined that really it's not worth restoring this receiver if we can't correct all of the problems on the amplifier board. So let's go over and look at that real quick. One last comment. It seems that sometimes this channel becomes more about me learning from all of you than from you learning from me. So again, I'm very appreciative. And for those of you who did email and so forth, I will respond to you personally via email. It just might take a while because I'm up to, I have a large number of emails that I may not be able to get to over the weekend. But little by little, I'll try to work on it in free time and get everybody answered as best I can. So anyway, back to this. So here's the underneath of the board. Down here is our amplifier board, and by a long shot, this has the most damage to it. And again, like I said, I'm not going to criticize anyone. I understand that sometimes when you troubleshoot these things, you tack parts in like this so that you can reuse them if they don't work for what you're doing. And this may just be what this was. I'm not going to judge somebody that I don't know. Obviously, they knew something because some of the things they were doing here were a little bit beyond just somebody not knowing what they're doing. So again, for whatever reason it is, this is the state that this thing's in. We have damaged tracks down here, and if I flip this around, hopefully it'll reach without hitting everything. And if we move the camera over, move our light a little bit, we can kind of see some of the things I was talking about on the amplifier board. I don't know if I can show that any better, if I can get a little more light on the subject, but you get the point. Down in here, you can see like some of these transistors down here have been just kind of, they clipped off the leads and just kind of put them in sideways. Some of these resistors have been replaced. Now this is kind of something that I noticed, and somebody else had mentioned it. But if you look in here where it says TH1, there is a little note in the schematic, in the correct schematic, talking about a little circuit that belongs in here. But you can see very clearly somebody put a capacitor in there. But if you look at the original side that has a little bit less work on it, this ELNA capacitor looks to be original to the circuit on the other channel. So this might be a mod that was done by Kenwood. I don't know. But again, we can see up here how this was kind of put in there. Here's a Sony transistor. And again, these are 2SC292. Some of these may be the correct ones. I don't know. So this definitely was a replaced capacitor. And I don't know that, and I think this was done quite a while ago, because I don't think these Nichicon, the ones with the green case, I think these have been superseded by either the KT series or the FG series. But these are an older version of capacitor, so it kind of dates it. I'm trying to figure out when this work was done. I believe this was done a long time ago, this repair job. And then down here you could see somebody tried to make up a capacitor with what they had in stock, trying to get this thing to work. These little transistors in these cases like this, although they did make silicon ones, this looks to be like a germanium, but I don't know. Again, we'll have to look at the part number, but it definitely, you look at the size of this one, and then you compare it to the size of this one. They are very different animals here. So what I'm going to do is I'm going to remove this entire module. Now that's going to require taking a lot of wires off and marking them and taking a lot of pictures. But we're going to need to do that because there's no way I can work on this properly and kind of figure it out without doing that. If we can successfully bring this board back, then I'm going to move forward and do the rest of the restoration. It's either going to be pass or fail at the end of this video. Well, the journey of 1,000 miles begins with the first step. So what we've done here is I've gone through and I've marked as best I could all the wires. I've kind of tied some of them down where I thought they would move to make sure they stay in their general vicinity when we remove this board. I've taken many pictures from every possible angle and every type of lighting I can to have as good of a record of this as possible. But the more I look through this, a lot of these wires have been touched by the soldering iron. You can see up in here, there's just burn marks all over these wires. So a lot of them I'm going to replace anyway. But what I did was I clipped the wire just a little bit off the board, just to give us a better idea of where the different wires are located. Some of them I actually used paint pens, and I just penned it in to mark it. This is just to get us a general idea of where everything goes when we put it back. Okay, the deed is done, the board is out, and now we can really see kind of up close and personal what kind of condition this board's actually in. It's gonna need some work. And we flip it over. Fortunately, there are some damaged areas, and you can see, look, they stuck this cap in and they never even clipped the leads off. So this was kind of done in haste, I think, trying to see what could be done to make it work. And I think they just couldn't figure it out, so they gave up. But we're going to clean everything off this board. We're going to take a lot of pictures from a lot of different angles, and then I'm pretty much going to field strip this board and clean it off, and we're just going to start from the very beginning and replace the components one at a time and see if we can get it to look better. So what we've done is I've taken both versions of the schematic that I have and I just enlarged the amplifier section. And then I printed them both out, and we're just doing some comparison. Now the first thing I notice is down here it says main amp 804. And when I look on my board, lo and behold, we have 804. If we look at the newer schematic up here, it says main amp UA13054. So they've changed the part number. The other thing I noticed was this one has a connector jack that you have to put a jumper in order for it to work. And I think the idea behind that was they would have you remove this jumper to set the bias, I think is what's going on. I'm not sure. And nowhere in this amplifier do I see that jumper. Now what I do see is right down here is a switch. I don't know if you could see it right there. That's a switch, and that is for the mains. So this is capable of 120 or 240 volt mains. And in fact, looking at the rear of the amp now, I see this sticker that says that it will do 117 or 220, 230 at 50 or 60 hertz. So that explains that part. But more and more, it's looking like this is the schematic that we have, which is the older one. And you notice there's no jumper. And they show these little PC networks, which is nothing but a resistor and capacitor in parallel. They also show these little TH in here, pins 1 and 2, and right here, pins 1 and 2. And if I show you the schematic for that, that represents this little circuit right here, which is one of these little diode networks in line with an SDT-06, which I can find no information on, that is shunted by a potentiometer, a 500 ohm pot. And those things, if you notice, pin 1 and pin 2 are placed right in this point right here on the schematic. So again, I'm trying to locate that on the, and that network does not exist on, well, I guess it does, but it's different on this other board. If you look on this board, they're showing that SDT20, and they're showing it being in here, and they're showing the diode on the board and then the potentiometer on the board. So the only thing that's off the board on that would be this. Nowhere on this board can I locate that quite yet. I'm still trying to figure that out. So after looking at things a little bit more, this is making a lot more sense. Down here you see this little network. So we have our little thermistor, we have our diode network, and we have our pot. And they're calling that TH1 and TH2. So you can see TH1 and TH2 over here. And they connect on TH2 and TH1 right here and here. Now these capacitors, and I'll show you why I say this in a minute, these are stability capacitors, and I believe they do belong in there, and this was a modification done at the factory before this thing shipped. And if you look on the back, there's a coax cable that we removed from here. So you can see where I cut the end off here, and here's the shield. And on this end, here's the cable, and here's the shield. And if we focus over here to the amp, I'll try to get you in close enough where you can actually see this. I'll show you one channel. Both channels are the same. So we have this pot, which is your 500 ohm pot. We have our diode network right here, and you can see the other end of this coax cable coming in, and here's the middle lead, and here's the shield. And then underneath this little clip is your actual thermistor that is thermally coupled to the heatsink. Now I feel better because this thing has thermal coupling to the heatsink. That's what I was wondering about. And then so you can see this little network where everything goes on there, and then down below, down there, is another identical network for the other channel. So that is your bias circuit. And of course, VR1 and VR2 will be your DC offset. And you can see how that would work over here, because this is before you get into your phase splitter, you know what I mean? So this is your DC offset, and then you have your two drivers, your two outputs, and of course this is a Class A push-pull circuit, which is why we have our decoupling capacitor, you know, between the outputs and the speaker. So what's happening is you have a single rail power supply, and they're calling it 68 volts up here, going into this, and these are both NPN transistors, so it's quasi-complementary because you have a complementary pair driving it. So you see your PNP and NPN going into a pair of NPN outputs, and these are actually raised up. You can see they want negative 34 volts because you have negative 68 volt rail. So this is actually operating in Class A push-pull, much like the Lafayette amp that we did not too long ago. So, and this is your decoupling cap. So everything is making sense now, and that's what this is. That capacitor was just added at some point, and it belongs there, so we will replace it. All this mess here I can't speak to, but we'll figure it out as we go along. But this is all starting to make perfect sense now. Now, comparing this board to the diagram of the later model schematic. So this is, if you notice, UA. So this is the model UA. We have the model non-UA. I'm assuming it's either the TK-80U or just the, well, it says TK-80U right on the front of the receiver. That makes sense. And you can see the boards don't even remotely match one another. You can see the print layout on this one, and you look at the artwork on the drawing of the 13054 board. This is the 804 board. You can see very clearly they're not compatible with one another. So there have been changes made between the two. The more I work on this thing, the more interesting it gets. So I've taken these transistors, and you can see I'm starting to clean the board off, and this actually cleaned up a lot better than I thought it would. The bottom is cleaned up, but we're going to have to repair the tracks, and we have some copper foil tape that we're going to use to repair all these traces. So that shouldn't be a problem. But what we're getting into now is a few things I found are very interesting. First of all, most of the transistors in the front end of this amplifier are germanium. And we're not going to replace them with germanium. We're going to replace them with silicon, but we'll get into that later. But if you look here, the drivers, these are the main drivers that drive the outputs. Believe it or not, you have a silicon transistor for the NPN and a germanium for the PNP, and I verified this in several of my books, including this one here, which is, and you can look them, I looked them all up and wrote all the specs down, and when you go over to this schematic, the newer one, these are all changed over to silicon. So we can actually do some comparing to see how they biased them. And we may need to change a couple components. We may not, though. Sometimes you can get away with it depending how the circuit is biased. But we'll get more into that later. But strangely enough, they kept the two germanium PNP drivers. They're the same transistors they use in this one. Everything else is silicon on this side. Now the other thing you'll notice in here is these little networks. See the resistor and the capacitor? And you can see they have two discrete components in there. But on the old one, notice they're calling them PC1, PC2, PC3. And I was wondering what the heck those were And as I really started studying this, for instance, where we at, this is not a capacitor. And if you look how it's rated, it's called R15-46. And if you look underneath, I don't know if it'll focus and you can see, but it actually says R15-46 silk screened on the board down here. So these are not capacitors. These are a resistor capacitor network. And they represent these little modules here. So these are all self-contained, and it looks like when the later model came out, they did away with it and just went with discrete components on the board. So we have a couple of options here. We can possibly see if the capacitor and the resistor are okay in this, which that would be very hard to test, and leave these in, or we can just make our own little network out of a resistor and a capacitor, because really it tells you what they are in here. For instance, this one is a 2.2K in parallel with a 50 microfarad. Same thing here, 2.2K and 50. This one's a different one. This one's 1K and 200 microfarads. So that would be these bigger ones. And then these smaller ones here would be the 2.2K with the 50s. So, interesting. This is fascinating. Now, the other thing is, this is an older design of amplifier. It's a capacitor coupled. So you can see the capacitors. It's not a direct coupled amp like a lot of the transistor amps that you see on that we work on in other videos. And all they're doing is very slowly, these are all single-ended stages, and they're just very slowly amplifying the voltage. So your voltage amplification is taking place over several stages. Normally you would see at the front end, you'd see that differential pair, and it would be set up with a current source that would give you voltage amplification, and they usually use pretty high gain transistors. Every one of these transistors is very low gain. So that's another clue that we may be able to just swap out a silicon transistor. Well, we're making good progress here, and I'm not going to show you the other side of the board yet. But we had to do a lot of extensive board repair on the back here because these traces. Just some examples that I found was there was a resistor right in here, and there's its lead is poking through right here. I've replaced it already. And you can see there's a distinct, you can see where these are separated. This track goes here, and this track is right here. And the lead from the resistor that was in here was over top of this, and there was a solder bridge right across here that when I cleaned this out, I found it. I'm finding all kinds of problems like this in here. The other thing is there are places where the tracks are completely gone. So right here, there's supposed to be a straight track between these two pins here, and there's supposed to be another one going from here over to here. So what we have to do is, I have this, you can order this online. This is copper foil tape. And it's actual, you can solder to it, and it's got an adhesive on the back, and you can cut it to shape. And you can kind of make little traces. So that's what we're doing right here right now. I've cut out this tiny little piece. And it's not real easy to peel. I'll see if I can do it on the camera. And I'm not looking in the viewfinder, so I don't know if I'm in focus or in frame or anything. But right like that, you can see how that's like that. Now, I'm going to have to do this off frame maybe. Well, maybe I can do it in front of you here. Once you start to get it peeled, it's very thin and very delicate. And here we go. See if I can get this off of here so you can see it. Normally I do this not around the camera. And I'm going to lay this down here just like so. Okay, here we go. Now we can get this down. And then I just Kind of lay it right there. And then you smooth it out. And I usually use just like a piece of little wooden stick or something just to get it pushed down properly. And you can just start to see the indents of the holes in there. And then you just take a sharp object. I'm just going to use this little pick. And you can perforate the holes just like that, so they're neat. And now we're ready to install the parts. So let me do that. Let me get the component pushed through the other side, and then I'll show you how we solder it in. So you can see we have the tracks repaired there. And I forgot to show you, I did this off camera. Before you put these little pieces of copper tape down, you really have to make sure the board is very, very clean. So you have to scrape off any kind of flux or anything, and then use isopropyl alcohol and hydrous if you can, so it doesn't leave anything behind, and thoroughly clean the board so that the adhesive will stick. Even with that, these things can peel up pretty easily until you solder them down. So you want to make sure you get as good of adhesion as you can. Once you do that, then we can go ahead and solder them in, and I'll try to do this around the camera so you can see it. I don't know how neat of a job I'm going to be able to do, but you just flow it on like that. And again, this is not going to be as neat as a professionally printed circuit board, but as you can see, it will work, especially with these old boards like this. And that's it, it's patched. You can see I did a patch. Where did I do it? I don't even remember. One of these over here is one that I made as well. I forget which one it is now. Oh, this one here. I did this one. This whole section was gone from here all the way down. So that's how you repair these types of boards when they fail. And that's about the best you're going to do. So the last thing before I show you the board that I have to deal with is these little modules. Now, one of the modules was missing, and that's what that big hack job on the back of the board with this and this was supposed to represent. I'm not sure what they were trying to do, I guess. But these are the two that were on the board, and what we want to do is, if you look on the schematic, these little modules are just a capacitor and resistor in parallel. So the big one is a 200 microfarad with a 1K resistor, and the little one is a 2.2K resistor with a 50 microfarad capacitor. Now, it's easy enough to test the resistance because, of course, once the cap charges up, you can actually read the resistor itself. And we can do that very easily by putting our own meter on here and measuring the resistance. We just want to make sure these are good. I don't want to have to try to hack anything on the board unless I have to. So you can see this is the one with the 1K resistor, and you can see the resistor is exactly 1K. And the 2.2K, very close to 2.2K. So we know the resistors are good in here, but how do we test the capacitors? That's really what we want to know, isn't it? So I got to thinking, and of course we can do some math and put some waveforms and things, but then I remembered I had this DATS unit. And this is a very versatile thing. You can buy it from, it's made by Dayton Audio, and you can buy it online. What is it? Parts Express, that's it. Parts Express. And this has the capability, this is really a thing for testing speakers and so forth, but it also has a really neat capacitor testing feature. So if we plug this in here, and we go up here, And again, I don't expect it to be perfect, but it should at least give us an idea, at least. All right. So we click capacitor and we click test. And it's going to do the sweep, and you can see where this is a 200 microfarad capacitor and it's reading about 279, which is what I would expect the way this is. The ESR, and remember these ESR tests are at higher frequency, so at 120 hertz our ESR is about 3.7 ohms. And again, some of this will, you're going to notice that at low frequency. Most ESR meters test at 100 kilohertz, so the ESR is going to look higher than it really is. But I guess what I'm saying is this capacitor, for all intents and purposes, looks like it's okay. It is acting like a capacitor, and even with that resistor in parallel, the DATS unit was able to pull that out. Now this one is supposed to be 50 microfarads, this little one, so we'll connect it. And we're going to click on test. And you can see it's reading 69 microfarads, which again, I would expect that. And once again, our ESR and everything looks good. So I'm thinking that these little modules are still good, and I don't see any reason that we will need to try to make a replacement of these. We're just going to put them back in and use them. So there's not really any high voltage on them. You can see this one, they're saying -3 volts, so it's very low voltage. So I would expect them to be good, and I'll test the other ones on the other channel the same way. Unfortunately, one of them has been removed, which is this third one here. So we have this one and this one are the ones we tested. This one, which unfortunately is connected to your DC offset circuit, there's a 470 microfarad, or I'm sorry, 470 ohm and a 100 microfarad capacitor here, and that I had to make up. And I'll show you that next. Well, after all that work, half of it is done and half of it is not done. So you can see this was the good channel, believe it or not. This one was in better condition. This was the one that had all of the really bad hacks on it. This has hacks, I mean, you can see, but this one took it to a whole new level. So we've replaced every component on this side except these two modules that we just tested. I changed the potentiometer because the one that was in there, even that one, had been worked on. And you can see right here where they had tried, these little rivets came loose and they tried to resolder it. So this thing was not very good. So this is a 30K potentiometer, and those I don't have, but I had a 50K, and what I did was I shunted a 100K resistor across it. Because two legs are tied together, as you can see on here, we can get away with that. So essentially that turns this into a 33K potentiometer. And the nice thing is if I, and I'll tell you why here in a minute, if I need to increase that resistance, I can snip this out and it'll turn it back into a 50K potentiometer, and it's a 15 turn, so I have a lot of adjustment for the DC balance. Now, one of the things I did was I tested these two germanium transistors and they were absolutely perfect, and actually they're perfectly matched with one another. So I cleaned them up and I put them back in. So these two are germaniums. Now, the one that was used for DC offset was also a germanium, and this is the original, what it looks like, what it would have looked like, but somebody put this one in there in place. You can see kind of they just twisted the tab around it. I ended up going with a silicon transistor because they're much more stable. The one that I read here had very high leakage on it, and leakage is a pretty normal thing with germanium transistors. You will see that a little bit on them. This one has no leakage. This is a Toshiba, a modern Toshiba, and this is an older Toshiba or Hitachi, I can't remember. And this is a TK-80U, and it has enough dissipation and everything. I don't think we're going to have any temperature problems, so I'm not going to heat sink it to anything. I think it'll be just fine. And these two, strangely enough, I think we discussed this earlier, these two outputs, originally the NPN was a silicon transistor and the PNP was a germanium, which is kind of a weird thing for being a complementary driver pair. So I replaced them with a matched set of SK3024 and SK3025. They're both silicon. They are both very good transistors, and they're new old stock. 5-watt dissipation maximum, so they're good. The only thing was this one, the NPN, was wired backwards. So you can see it should have it. This one is wired emitter base collector, but the original one was wired collector base emitter, which means I kind of had to bend the legs around a little bit to get it to fit. You can see this one was wired properly, so it just fit right in the old socket. This one, we had to bend the pin in the middle and flip the thing 180 degrees, but no worries on that. It worked out fine. So everything's been replaced, and yes, the resistors are all kind of hodgepodge because I just used what I had in stock. I'm not going to put any money in this really, other than what I have in inventory. So if it doesn't work, well, we're not out that much other than some time and a few components. Now what I'm going to do off camera is I'm going to finish this side. I'm going to make it look just like this. And you can see we haven't done anything on this side. This side we cleaned up as best as we could. It's not perfect, and there's a lot of, you know, this foil tape in there from all the broken tracks. Some of them you probably can tell in there. Some of them are hard to tell that they've been replaced, but there are quite a few of them in there. I think I got it all right. We'll know when we power it up. Hopefully we'll at least have something to work off of. So I'm going to end this video right here, and off camera, before we do our next video, I'll get this one done so it looks just the same as this, and then we'll be ready to do some tests. So in the meantime, as always, I wish you all peace, joy, happiness, and good health in your lives. And I look forward to seeing you again soon with our next episode in this series. And until then, stay well, and we'll see you soon. Bye-bye.